All right, so it's a great pleasure to have Kasia Rejniak here. She is from the famous group at the Moffitt Cancer Center, and they have been for many years a leading force in the mathematical modeling of cancer. And so I'm really happy that Kasia has time to talk to me a little bit. And so why don't you introduce yourself just quickly?
Thank you very much for inviting me. I'm Kasia Rejniak. I'm originally from Poland. I did my PhD at Tulane University in New Orleans in States. And as you said, I am now a faculty at the IMO at Moffitt Cancer Center.
So how long have you been at the IMO?
So I am one of the founding mothers of the IMO. I came there at the very beginning at 2008.
2008, oh yeah,
Yeah.
that's quite a while ago.
Quite a while
Wonderful.
ago.
Yeah. So before you came to Moffitt, have you already been working on cancer?
So I started working on cancer when I did my first PhD at the Mathematical Bioscience Institute.
Oh, okay. Yeah.
But the inspiration were actually my friends when I was a graduate student. I have friends from Poland who came to do the postdoc, biologists, and they were all growing cancer cells and only talking about the cancer cells.
I mean, you
So-
mean in the lab growing, not in
In
the
the lab growing,
In the
yeah,
lab,
yeah.
yeah, right, yeah.
And then, so when I started my postdoc, I changed the model that I was developing to model cancer.
Oh, I see.
Growing
Okay.
cancer colonies
Yeah.
and spheroids, yeah.
Yeah, I find it fascinating whenever I hear a talk of yours, like today as well. I'm really surprised. You bring in always new ideas and new thoughts, which are maybe not so standard, which is really nice.
Yeah, that's what I like to do, yeah, to develop new models, yeah.
Now, this Moffitt Cancer Center is directly related to a clinic.
Yes.
Can you explain a little bit how the work goes at this cancer center? How do you get in contact with clinicians?
So this is the Moffitt Cancer Center and Research Institute with the clinic, like you said. There is a group of biologists and then there is a group of clinicians. And, well, you just have to knock and talk to them.
Oh, I see. So you just go up to the
So-
door and, yeah.
So the clinicians, depending on, how they view themselves, some of them do only clinic, but some of them have also research days.
Right.
And they are parts of the research groups. So the clinicians that I am working with was part of the group of the immunology and in the bladder cancer center, in the bladder cancer, working on bladder cancer.
Mm-hmm. Okay.
So that's how I met him. So I started working with biologists, but he was part of the group because, like, everything what you do at Moffitt has to have some, like, view how it could be used in clinic.
Yeah, of course, which is a very good question. Yeah. But do you have the feeling that the doctors are interested in your kind of research?
So more and more, I would say.
Aha, okay.
There are some who already also developed some network models, for example. Radiologists were always interested in
Okay.
some of the mathematical models. And at Moffitt, so IMO is one group, then of course we have biostatistics, bioinformatics, we have epidemiology groups, so there is a lot of groups who analyze the data quantitatively, so that's what they are always interested in. And
Yeah.
we are trying to bring those mechanistic models. I mean, I also do mechanical models, but mechanistic models.
Mechanistic and mechanical models, yeah, right. Yeah, but as you
them.
mentioned data, this is indeed the case, right? We get more and more access to data and
Yeah.
really, really good data. So do you see opportunities for your own work in using those data?
Yeah, so for a long time I was working on preclinical models, but now we are starting more and more with the clinical data.
Okay, right.
The one that we have access to right now, it's the feasibility clinical trial at Moffitt, so it's one at a time, so we don't have as much data. That's in the trial there will be only 12 patients. We have access to 130 data sets from the past.
So how is
So-
it working with the trial? So I've never been able to do that myself. Is this lots of preparation, proposals, getting patients and so on? Is this complicated?
It's complicated. I didn't expect that there would be so many meetings, which I was not really active part, but I've heard about them to actually organize that, right? Because
Right,
when the
yeah.
patient comes, the whole team has to be prepared to do tests, to collect the specimens, and then the specimens have to be either in red cup or green cup or blue cup, depending on the color. Then it goes into different depositories, and then some, of course, is going to pathologists, for example, to test, and some is going to our collaborators in the experimental lab.
Yeah, this sounds really complicated.
So, yeah, I didn't know that it will be. It's really like before every patient comes, there is like several meetings to have this actually organized and be ready for the patient.
Amazing, yeah, very good. And so how long is this test or this trial gonna run?
So this is feasibility trial, so it will be for 4 years, and we will have 12 patients, and it's to test whether the procedures are safe. So this is to do the adoptive therapy intravesical, so through the catheter to the bladder, and it has to just test that
it's safe.
That it's safe, it's not toxic for patients, and then of course the secondary is, are they successful, right? But the goal is to show that they are safe.
Yeah.
And after that, there may be next trial.
There might be a next trial.
If this is successful, then there will be another one. Yeah.
Yeah. Yeah, this is a really new dimension for mathematicians.
Yeah, for me too.
Yeah. Now at Moffitt, you have a chance also to work with many young people and students and postdocs. Do you have a program?
So we have several programs. So we of course have postdocs. We have the graduate school. It's in the cancer biology, but there is mathematical oncology track. So every year we have a couple of students. We have a lot of undergraduates from the nearby universities who volunteer. And then we have the high school summer school program every summer.
Oh, wow. Okay.
And so this year we have more than 150 applications.
From the high school?
From the high schools.
Oh,
and
nice.
We accepted 15 students. So
yeah,
this program that started with Heiko Enderling, and then Rene Brady is taking over, and we have more and more applications.
Oh, that's wonderful. Yeah. So what advice would you give young people if they want to enter this area? What should they focus on?
So, so this is interesting. So I think that, you never know what kind of knowledge you can use.
Yes.
So they should learn as much as possible, because you never know which part will be useful. The ideal, which I'm not like that. We have one faculty who has the wet and dry lab. So ideal would be if they can do both, experiments and math and modeling.
Yeah, right. Okay.
But so that would be, I think, be great to have the future generation like that. But even if you are only, what they say, dry lab, so not doing the experiments, whether you like to learn, machine learning or statistics or image analysis, all of that we are using. So it's
and
not
it sounds
math
like
only.
Communication will be important too,
Communication
right? That you can
too,
talk to biologists or medical people.
No, that's true. That's true, yeah. But that's comes also with time, right? You have to try and talk to them.
Yeah, very nice. So where do you see our field going? So what do you think is the next developments or directions?
We are now entering, so when I started, we were happy to reproduce some data, but now it's more and more to actually predict something that could be tested in experiments or have predictions that could be taken to the clinic. Maybe this is biased because I am in the cancer center.
I mean, you have a close contact with clinicians, right?
Yeah, but
not
that's kind of And then, of course, every patient, cancer is different, so these ideas about the personalized treatment, I think it's something that, that will be the future.
This will be the future, I believe that, Yeah, great. So then thank you very much for having the time for this interview, and it's great to see you.
Great being here. Thank you for the invitation.
Thank you.
Thanks.